Okay, here we are in the shop, and I'm going to make a bandsaw stand. I know the very first thing I need to do is make the frame that's going to carry the wheels, and I'm using 2x2 angle iron that's 3/16. It's a little bit thicker than 1/8. I felt that this thicker stuff would be better because I was going to actually put some bolts in it. At this point in my build, I wasn't exactly sure where the bolt holes were going to go or how exactly the mechanism was going to work, but I just had a gut instinct I would be able to figure it out. And a lot of people ask me, why do I use the bandsaw over chopping saw? Bandsaw, I have more control, and the metal dust sort of keeps down to a minimum. It doesn't get sprayed around the room. And then unlike a grinding disc, it doesn't run the risk of creating a fire with the sparks. So it's just much cleaner to use a bandsaw, and you have more control over your cut. So another reason why another thing people ask me often is, why do I make these sort of weird lap joints for the corners? And if you cut a regular 45-degree angle, you end up with really sharp, thin pieces of metal that just melt away anyway. So when I do this, it's just full thickness of metal getting welded to full thickness of metal. And you see I left those corners kind of open. I got a little scared of my dimensions at the last minute, and I just spread the whole square open a little bit, which is why those corners just basically meet at an open corner. And I knew I could fill them with weld, so I wasn't overly concerned. So that's what I ultimately did. I just opened the frame up a little bit because right after I put it together, I just double checked, and I got nervous that if I went with my original intention, it would not fit on the base easily. And I'm using this new angle grinder, which works great. It's a cordless 60 volt from DeWalt. And now here I'm making the caddies that are going to carry the wheels. And you see my little stopper there. It's just I use these screw clamps I get, these machinist screw clamps I get, and I just create a stopper and a little carriage. And believe it or not, this bandsaw cuts fairly straight. I just try and stay perpendicular to the table there, and you can see all those are cut on the bandsaw, and they're all almost perfectly 90 degrees. And now again, for repetitive cuts, I like to do this spray mask. It just gives me a quick cutting guide, and they're all the same. And I have 4 left and 4 right, and each one of these will get welded side by side, each pair, to make up a cantilevered wheelhouse. I just did all of one side, now I'm doing all of the other side. And this bandsaw cuts are obviously sped up. Okay, there's 4 and 4. And now there you see I have 4 left, 4 right, and now I'm going to tack them together. Get my settings right, get my gas on, turn on my fume extractor, and when you weld, you have to be conscious of where the metal will pull in the direction of the weld. So that's why I like to tack, because I don't want to overheat the part and then it deforms the part. So I just like to do a bunch of tack welds, and call me crazy, but I also like the way it looks. I'd like a bunch of riveted tack look as opposed to one long bead. So for me, it's utility in the way that I don't want to overheat it, and then also I like the style. And then I realized I didn't have enough clearance. So here I made a little bit of an adjustment in my original design. I thought those wheels were going to be completely underneath there on bolts. And now I realized I needed to cut part of the wheel base off because I didn't have the clearance. The wheel did not spin one full 160 degrees. It bumped into the sides of the ramped up edges there. So I just welded them in place. It was a change of plans, but it's fine. And then a lot of people will say, well, that's great. How do you fix it? I just created it from zero. It didn't exist before me. So I can certainly replace a wheel if I needed to. I just take it in there, put the die grinder, cut the welds, and just change it out. So a lot of amateurs will watch this and go, well, that's great. How can you fix the wheel if it breaks? Like I said, I am the god in the world of this object. I can take it, leave it, fix it, modify it. I'm not worried. So I'm just making my welds look good. And then I realized I get some welding splatter and some grinding powder inside of that bearing chase, and it's not good. So I taped up the bearing chase to keep any of the welding splatter out. And now this is where the cantilevered wheelhouses get tacked into place. I make sure that everything seems level. And then I just really wad that weld up there so it gets completely filled. And I'm using Cubetron discs, 60 grit Cubetron discs from 3M, and they literally eat the metal away and they stay sharp for a very long time. And you can see that. I know this is sped up, but it's not that sped up. These things just devour steel, and they last. Cubetron grinding flap discs. And now here I am, I'm done with the first phase, and I have no idea how I'm going to do the second phase, but I just start cutting, and I start. What we have there is 3/8 thick, 3/8 thick cold rolled steel, 2 inches in girth, so it's 3/8 by 2 inch cold rolled. And I know I'm going to tap into this, that's why I want the strength. I also want to make sure that I have enough threads through the thickness of this hole. And then it's also just some thick, nice, clean metal to work with, because I'm making 3 feet and 2 levers. And there you see me tapping and tapping. And this is a 3/8 16 thread. And on each one of those parts, one hole is going to be a carrier hole and the other hole is going to be a thread hole. So one will be a pivot and one will be a thread, if that makes sense. And now here I am drilling the frame. Again, I had that nice 1/4 inch steel in the frame, or 3/16 in the frame. So in the frame there I have 3/16 inch steel. It's going to carry a few threads. And my original plan was to weld them once I screwed them in, but I did not ultimately weld them. I just tried crazy glue. If it becomes a problem later, I'll just have to weld them. And now these are my lever parts. And I'm not going for style here, I'm just going for utilitarian. And these are going to get connected by a big long bar. This is all just a theory right now. I had already tried one attempt, a lot of trial and error, but that's boring to put in the movie. So I tried one attempt, I realized I didn't have enough ground clearance in the up position, so I had to cut this whole corner off. And then when I cut this corner off, I realized I needed to re-square it so that the bolt is directly over the flat foot. And I had another problem. The lever that pulls the 2 feet down, and the pinhole in the lever and the pinhole on the 2 feet are at different radiuses. So this had to slide through an open keyhole there, and that's what I had to do at the end of this rod. I had to cut it off and turn it sideways and make it so that the radius traveled in a different path than the other 2 radiuses, and you'll see what I mean in a minute. And now just for styling, this stuck up over the top when the wheels are in the up position. When the feet were in the down position, this stuck off in the air, so I cut them off. So now everything should be proper this time. I put it all together. And in these few dry runs, you'll notice that I don't put washers in between, and I also do not crazy glue the bolts, but I'm just going for making sure this is just a dry run. Now here I didn't need to worry about the connecting rod. It's just 2 pivots, so there was just 2 radiuses. So now here you go. And we have action. It's a little loose still because I haven't driven the bolts home. And now this is the lever that's going to operate the back and the front together at the same exact time. And I give it a quick tack, and I want to just make sure that everything seems to be copacetic. It seems like it. And then I drive it home. And again, just cleaning up that grind, and now I should be good to go. Now from this particular take in the video to the final, I took it all completely apart and put washers between all the connections, and I used CA glue, and now here you can see the washers are in between the connections. I use CA glue between all the bolts, so anywhere the bolts are screwed into threads, it's flooded with CA glue. That's to keep them from backing out. And it seems like it works. Needless to say, I put the feet in the perpendicular direction to the bandsaw cut, so when you're pushing wood through, you don't run the risk of it falling off its feet. And it works pretty good. My ground is still cockeyed, so the frame needs to be attached to the base. And I'm going to put a couple of self-tapping screws through the base directly into the frame. There we go. A lot of trial and error, but it works.